In this optimization problem, we're building a window. The window is being built and the bottom is a rectangle, the top is a semicircle. If there's 12 meters of framing materials, what must the dimensions of the window be to let in the most light? Well, let in the most light is a fancy way of saying we want to maximize the area. Okay, so again, let me write what I want to maximize right over here. And this, this is really important to know exactly what you're going to maximize. Write this equation right away. So we need to maximize the total area. Well, it'd be 2r by h. And again, if you're wondering how I drew the picture here, the radius is r, so the rectangle, this whole thing would be 2r. Okay? And area of a circle, of course, is pi r squared, but it's only half of the circle. It's just a semicircle, so I'll just put plus 1/2 pi r squared. So this right here is my optimization equation. Now, two variables, like everything else, we need to use a constraint equation. I'm going to put that right over here under the picture. Our constraint equation has to do with the 12 meters of material we have. So the constraint in this case, if we think about perimeter, we've got h plus 2r plus h, so we've got two h's and a 2r. Let's start with that. 2r plus 2h. And we also have half of the circumference. Well, circumference of a circle is 2 pi r, but we only have half of it, so this right here is just going to be pi r. So 2r plus 2h plus pi r is equal to 12. Well, we could do some solving here for h maybe. We could do 12 minus 2r minus pi r all divided by 2 equals h. Maybe clean that up a little bit and just have 6 minus r minus 1/2 pi r. Maybe that would be nicer. I don't know. Okay. So now we're going to take our constraint equation and put it back into the area. Okay, we know that this is equal to h. So area is equal to 2r times h, so 6 minus r minus 1/2 pi r plus 1/2 pi r squared. Let me do a little cleanup here. 12r minus 2r squared minus pi r squared plus 1/2 pi r squared. So we keep going. I got 12r minus 2r squared. And if I have a negative pi r squared and a plus a 1/2 pi r squared, then I have a net of minus 1/2 pi r squared, right? Because they're like terms. And you had a negative 1 and you added a positive 1/2. So this is about as simple as I can get the area equation. So now let's go to dA dr, or A prime. We got 12 minus 4r minus pi r. Okay? And we want this to be equal to 0. Well, let me do this kind of right away. Let me move the r stuff over to the other side. Okay, let me take both things and move them over. So I'm going to have 12 equals 4r plus pi r. If I factor an r out, got that, so I could just divide like that. R is equal to 12 over 4 plus pi. Okay, and that's the radius. So to get the height, all I'd have to do, all I'd have to do is plug that back in here and solve.